Hello droidCon, hello from my bedroom. Hope you are staying safe and healthy. So today's topic is reverse and inject. It's focused on the Android security side mostly, and I know today it's not very detailed. It will not be very detailed session because the format of droidCon, but I will try to explain the surface, how we can tackle Android applications, how to reverse engineering them, what are the key differences between static analyzing and dynamic analyze, and also how we can work with the native libraries, these SO files in Android APK. And lastly, I'll show you how we can repackage some of the applications and how the other markets and the official Play market applications are manipulated. Yeah, so I'm Tato Kutalia. I'm a chapter lead in the TBC Bank, the biggest bank in Georgia. So today's plan is the first to get to know the tools, the names, the terms, how they are called, and then, as I mentioned, static analysis and reverse engineering. So let's deep dive into this. Okay, now first let's say that what is a static analysis and what are the disassemblers, because and what is the dynamic analysis. Yeah, static analysis is when we run, actually we don't run, but we reverse engineer, decompile our application, and we analyze it without running the actual application, but we deep dive into the code. We try to trace some interesting functions, some malware code, yeah, and yeah, that's it basically. And mostly as an Android developers, we have done this at least once in our career, using DEX2JAR, I guess, or JDGuy, or JDEX. There are tons of tools when we are interested in some other applications, like to get to know what libraries they're using or how they manage to write some Dagger components, how other applications are built, and it's really easy on the Android to do. But on the other side, we can also check some malware applications and understand how their code runs and how the attacker's mind works, how they trying to exploit the Android framework itself, the permissioning system, how they target the users. And it's really interesting to understand other people's code. So that's how I started this static analysis, because I was always interested in how others wrote those applications and how others managed to overcome some problems. So static analysis is the first step and the easiest step to step on. So first is JDEX, which is a cool compiler. The compiler actually is the APK tool. So APK tool actually gives us all the resources, and we can change resources. We can change the Smali files and then repackage them. So we will need the APK tool quite often, and I'll show this in demonstration. And several weeks ago, the new version of APK tool became available, which offers a better APT compiling. So there are some details that you will get to know later. And there's another version of this decompilers, which is DEX2JAR. And I guess it's most famous, but the difference between the JDEX and DEX2JAR is that the DEX2JAR, as the name suggests, decompiles DEX to the jar. So we see quite different codes as a result, rather than see it in the JDEX. And then on the next slide, I have some graphs about it. And JDGuy is the compiler plus the very good code browser for your decompiled code. So on the other hand, we have disassemblers. So disassemblers, it's as the name suggests, they disassemble the files which are native files mostly, and the platform-specific code like IRM code, x86, x64 code, and of course it's not limited on the Android libraries. They are used widely on every platform, like the binaries, Windows executables, and everything. So we have two famous options here. I know there are more, but we have two main, which is Ghidra, and ironically, it's open sourced by NSA. So yeah, and IDA Pro. It's a free and plus pro version. So both of them are great. And so keep in mind when you dive into this field, like the security, Android, reverse engineering, everything, that there's no tool, a single tool that can do everything. So yeah. So we need to have several tools, a multi-tool chain to tackle a single problem from different sides. Like the Ghidra doesn't have a actual embed the debugger, but on the other hand, IDA provides it. But the Ghidra can disassemble files and show us on translated C code level a better and it's quite easy to read those code, unlike the IDA. So you can choose one tool over another. And lastly, the dynamic analysis. What is dynamic analysis? Yeah. So dynamic analysis is when you actually run your application and analyze it on the fly, and you can change the behavior on the fly. But let me clarify. We will have the demo on all of this, but to clarify what the FreeDye is. So FreeDye is that when you have your application to test it, to test the behavior on your emulator, sometimes applications have the restrictions for and checks for the root device. Sometimes they have country detection. Sometimes they have some kind of user levels on right, so admin rights, for example, test user, and some kind of restrictions for the user rights. So via FreeDye, you can bypass them on the fly. So FreeDye can be installed on the rooted device as well, a normal device, but on the rooted, and it hooks to the memory. And now you can change some memory. You can actually overwrite the functions, the Java typical Java function methods, and plus you can change the return value and everything. So this gives us the ability to fully engage with the application. So let's talk and let's deep dive into more detail. So this is the application structure we all know, but just to remind ourselves, the manifest file, meta-inf, which is signatures and meta information. The main part are in the classes DEX, which contains the dalvik bytecode, and the lib folder, which is for native libraries. If you have not written any native libraries, that's not the problem. But when you assemble your release application, and if you use some kind of Google ML kit or some dependencies which are heavy processed and does the heavy processing on the device, they're most likely written on the native code. So they come with the already precompiled SO files. So they will be in the lib folder in your final application, even you can notice it during the development, and the assets, of course. So now I want to stop your focus a little bit on this graph, how it differs the Java and Android compilation phases. Yeah, on the left-hand side we have the Java, which is just Java bytecode. Compiles it on Java bytecode, and it goes to the Java virtual machine, which is stack-based actually. But on the other hand, on the Android, we have Java source code, which is compiled using Java-C to Java bytecode, and then we have the DEXer. Actually, it's called DEXer. It's a DEX compiler, which converts this to the Dalvik bytecode. So, and the actual result is the DEX format file. The classes DEX, in the classes DEX folder, we see lots of Smali codes later. So, and this register base. So when we choose the compilers like JDGuy, like text2jar and JDEX, the key difference is on which level they operate. Is it from the DEX to it's from DEX to the try to revert to the jar, or they just try to decompile DEX and give us more raw code? So we will read mostly Smali. Okay, JDEX can then translate Smali a little bit, but it's still more raw than the compile to the jar. Okay, and this is a very quick comparison between the actual Java and what the Smali look like. And there are some resources if you want to understand the small Dalvik opcodes, because it's register based. So yeah, that's basically it. That means the Boolean and B byte, and you will need to understand Smali, and sometimes you need to write Smali as well. Okay, now I have some reverse engineering way, small demo how we can actually reverse engineer something and understand the internals of the application. So I have some random application which I pulled from the Play Store. It's like Disney Plus application, and I used JDEX, simply JDEX, open JDEX guy, and drag and drop the application here. So nothing very special and nothing very extraordinary. Just I wanted to show how the minified application might look like, how the names are minified here, and the JDEX gives us actually an ability to rename those classes. Like we can have this here device, for example, test device. If you rename here, it takes time because it's a large application, but yeah. Now we have test device, and everywhere it's used, and we can find that the references declaration is everywhere now test device. So this helps us to rename and retrace code much easier. So I know this session is very limited on time, and we can't deep dive very small details, but I want to show you some dots and some interesting details which may lead you to those kind of things. So okay, and you can see all the structure here, how the normal application looks like. So let's get back to the presentation, and I want now to talk about some SO files. So as I said, the IDA Pro and the Ghidra, two main applications to disassemble native files, and one looks like this on the picture, and it's actually lists all the assemble code for us, and we can trace it, and we can debug it if we want. And debug, it's a fancy word for this context for the Android, but actually, yeah, we can at least read. And some new exploits which are on the market, which reported already. Some this exploit pointed the vulnerabilities in the native level code, not in the Android applications, the Java level. No, it was on a native level, on a native image processing libraries and stuff like this. So yeah, it's very interesting field to research. And yeah, now we have another variant of the disassemblers, which is the Ghidra. Yeah, so in Ghidra I have now opened the libyoga file. So it's a Facebook library, so yoga library, and some part of it, and you can show on the right hand side it's how it looks like after the compilation, and on the left hand side you can read this assemble file, and Yeah, also we can trace and rename, retype variables, or we can do all the stuff around it. Yeah. So dynamic analysis, it's very not well researched in the Android security field because it lacks documentation. Really, it's awful. The only good documentation you can find is not the official one, it's the one written by the researchers, by the Android developers who were interested in this tool. So bear with it. It's a freedom, and we can do all the stuff, all the good stuff with the Frida. So let me show you what the Frida can do. Now I have the rooted emulator here. Yep, rooted emulator. And okay, so Frida is already installed on the rooted emulator. I will show you in the next slide how we can install it on the standard device. But on the rooted emulator, you just have to download the Frida server, which you should choose using how your CPU architecture is configured. It's like ARM or x86. You can download it and run it on the background. So then Frida can list list and write down all the running applications with the process ID. For example, that's a demo. So those are the applications with the process IDs on my device. So okay, now I'm going to show you what cool example. So now we have here one application, which is just simple application, and I'll show you what it does. It's a broadcast receiver, just broadcast receiver, and the second application just sends the broadcast. It's a simple demo. So okay, I will show you the code in a moment. Okay, let's JDEX guy, let's run it again, and I want to show you the receiver party. So it's quite dumb. Just does the only thing it's required. It takes the on receive callback. It gets a string from the intent, which will be sent from another application with the name, the extra text, or null. So the only thing for this application to do is to toast some kind of intent it gets from another application with this same authority. Yes, the Tato cluster. So that's the only thing. And let's see it with the demo. Now you can see the broadcast received, simple message sent. So broadcast received, and it is shown from another application. This application, the broadcast sent. Now let's try to override this broadcast receiver callback on receive. And more specifically, I want to not just to make the whole method overriding. No, I want to change the intent, the string value inside the intent. So I will point on this intent object, and I will try to override this getString extra to return any value I want. So here it is. Okay. So first of all, there's some kind of boilerplate you need to have. It's if the Java runtime is available, and then the perform. So you can do Python scripting or JavaScript. You can of course use both of them, but you need at least one of those languages. So I use JavaScript for now because I think it's easier to display on this presentation. So here I load the class I want to just simply use. Java use Tato cluster exported broadcast receivers. This name comes from here. I decompiled application, and I know what to attack. not the attack, but how to tackle and how to bypass or how to change some value in the runtime. So then I have the target has on receive, on receive method, which I want to hook into this implementation, and it takes this parameters, context and intent. It's just like copy paste those, and then inside it, I want to overwrite this get string extra, the right custom implementation, and for the intent object, which get string, and this will log the actual string and return the custom variable, so custom value I want. And then I also console log that on receive is accepted and here, and then I continue to run the normal method. So it will continue its runtime, but it will be changed because I changed the behavior. So let's see how we can actually use this. Okay, so I have already predefined. It's minus U. It's via USB connected, but it's not. Now it's emulator. So those parameters and to run the local file. Okay. The key thing also is that it's like debugging. So it will not run the actual application. It's stuck on the white screen because sometimes applications do the device check, root check on the very start of the application instance. So you need to hook on the earliest moment in the application lifecycle. So that's why Frida freezes the application execution, and we can do anything we want. So also we have the method tracing and the memory tracing, everything with the Frida. So it's a huge tool, but not very well documented. So okay, resume. And I resume normal flow of the application. It's quite normal, looks normal. Now let's send some kind of broadcasts. Oh, okay, sorry, I have not saved this script. But the key thing is that you don't need to recompile because it's hooked into the memory in the runtime. You can just change your script, and it's on the fly updated. Yeah, Frida is so cool. See? Now if I change some plus test, save, command save, and yeah, it's updated. So I think it's really dumb demo, and you will agree, but it shows how powerful this tool is. So keep in mind that this tool will be in your toolkit when you actually need it. So, okay, what about the Frida gadget, which is run for the non-rooted device? So yeah, it's a little bit struggle, but still. And now you need some Smali scripting, at least one line of it. But there are tools which will do this automatically for you. But when you start with, it's better to know how to do everything by yourself, by hand, and then switch to the automatic tools, because tools can't replace your knowledge. It's better to know yourself and then try to automate those things. So first thing first, decompile application, add this Frida native library, which you have to download it from the Frida GitHub, and then inject it to the bytecode, and this is how injection works. So we know from the applications that the system call, the load library, it's available in the JDK, in Android, and then we call system load library FreeDAGadget from the very first entry point in the application. So maybe in the application class. If application class is not present in the application, we can edit, and we can edit later via Smali as well. So we can do all this stuff with Smali. And this call system load library is the same as to translate it to the Smali code. It's to define some constant string and to invoke static methods. So it's quite simple. If we add this at the very start of this first Smali file in the header, it will run FreeDAGadget first. So that's how we do it. Add permission, repackage, sign, and install. That's easy. And that's why, because it's easy, that's why it's automated by most of the app. So scanned applications, I scanned several applications for Android application. The problem mostly is that it's only sometimes a client-side validation, and it sucks. And I discovered many of these vulnerabilities in applications like mobile is an OTP, PIN, email enumeration. Sometimes base64 decoding is not working and leading application to crash when you upload a huge image. Sometimes local SQL injections, bypassing OTP and PIN code because it's client-side validation, leaking Google API keys without restricting APKs are bundled with test features in production applications, some test URLs, and all those kind of things. And you can actually report these to the companies and take the participation in their bug bounty programs. So I want also to talk about the catch the flags. What are the catch the flag challenges? So those are the challenges that you can exercise, and you can train yourself and see what are the common vulnerabilities and exploits in the wild. And there are very special websites for it, like the Hack the Box, and also HackerOne has some. And I know that those Android challenges are, let's say, very small amount of whole challenges, but still you can train yourself and see how it goes. So you need to always try to dig deeper, and it becomes more and more interesting, and that's basically the rabbit hole. So at the end of the presentation, I want to show a simple demo which how we can inject some kind of code into the application and then repackage and resign. But it will not accept it for the Google Play Store because it's not signed by the official developer unless you have signing key. But also this shows the danger from the external markets and why we should not trust external markets. So I want to, for example, I have the application, this toolbar, just dump application, shows the toolbar, and I want to inject some kind of code, malicious code, which is run on every app start. This will be a broadcast receiver on app restart, or very cool hack, the content provider, which will be run on the every app start before the application. So you can always rely on the content providers because they are always run before the application starts. And it's a cool hack which is used by the Facebook SDK itself and also Leak Canary library. So both of them are by default loaded when your application starts. So they don't need any configuration, just include them into the build. It's a Gradle dependency, and it's okay. It's done. So that's a cool hack they are using. So you can also use this to inject some malicious code. That's an educational purpose, and of course you should not do this. But to test the limitations of Android and how Android develops during the during the time, and you can do this. So okay, we can just take another application's package name, generate our malicious code application like the boot receiver, and then we build it, and after the build we will have the application, and the application we can then decompile it. And then so we will end up with a Smali code for our application, like the broadcast receiver, yeah. And we can just drag and drop those into the original application. We want to inject this code, like here. It's already done, and I don't want to waste the time here. Here, upload service, boot receiver, build it, repackage it, sign it with some kind of dump certificate, and that's how many people are infected by malicious applications, because it allows the other guys to inject some kind of code. But that's not the point of this presentation. The main idea is to show you how we can reverse all these things, and how we can actually fight against those applications, and fight against the malware, and what the tools are available, and how powerful those tools are. So now this will be restarted and shows some kind of toast which I overridden with my malware code. So it takes time a little bit. So it's boot receiver. Yeah, it's the toast from the my code. So yeah, if you have any questions now, the QA session is open. Thank you for your time, and I'm available at Twitter and everywhere on the web. Thank you. Okay, first question is, if an app is using app signing by Google Play, how would you repackage replace it would work? Yeah, that's a good question. That's the very good work is done by the Google, that now we have the Play Protect on our applications, which eliminates most of the application, and it's app signing, the very good option from the Google. So yeah, this will not replace actual Google application on the client's phone, but in the countries where some applications is restricted by the country restrictions, some legal restrictions, there are many bad developers who create the code, the malicious code and malicious application to target those vulnerable people and create duplicate applications which tricks and which abuses permissions. So you can bypass Play Protect, at least what I know for now. And yes, those are for the people who press OK, allows it to install this application because I really want the TikTok on my phone, and I can't install from the Play Store, and that's how it goes, this whole story. How much device can be hackable from Android shell? So I don't quite understand what you mean from Android shell. If you refer to the terminal applications which can be installed on the custom Android ROMs, yeah, it's quite possible. You can the actual device can be hacked so easily, but you need some kind of chain to hack the actual device, like the break in the networks, and maybe do some social engineering and how to target them. So it's not the one thing that okay, I want to hack Android today, because you need to find some kind of exploit and then chain several scenarios to actually get the result. And because this session is not about the hacking. This session is how we can actually defend our applications, our businesses, and people, the users, and how we can monitor everything around us. So another question is, thank you for questions, and I appreciate it. Could you recommend any books, articles on Frida? The official documentation is not the comparison. Yes, Abba. Yeah, official documentation is not very good, and unfortunately, the books, there are no books on stuff like this because it's very quickly evolving, and the books can't keep up. So articles, just Google. I don't know any other better options. Just to Google and read Medium articles. Maybe someday I can write some articles on Frida. I'm not sure because there are more competent people in the world who know much more on Frida than me. But yeah, you need just to Google and read the manual. So -- help and read it. Any tools will. So another question: any of the tools will work on non-rooted device? Yeah, of course. The Frida works for non-rooted device. Just you need to take some extra work to work it. But yeah, but this thing is that when you try to do all these things, you need to set up some kind of lab, the laboratory. So you need to have rooted emulator, non-rooted device, also rooted device, non-rooted device. And for the Frida, if you have the rooted device, you can then override some checks, methods to bypass the root check. So it's not a very, very big problem to have the rooted device. But yeah, in general, Frida can work on non-rooted device, and that's it. Can you suggest any blogs, any books for reverse engineering the Android device? Okay, that's a good question. Unfortunately, no, I can't because I have not read any books on this. I've been developing Android applications for 5 years already, and plus I have some engineering experience, and all this experience led me to just explore the other side of this, and it's now much easier to tackle and reverse engineer my own work, for example, and I know how other developers also think. So I can't recommend, but I can recommend very cool YouTube videos. You can just Google Android reverse engineering videos, and there are a bunch of them which are really cool. I've gone through several tools, but none was working on rooted device. So first thing, do we need to root the device? Is the recommender. Okay, I don't know which tool are you referring, but if you refer to some hacking tools on the market and you can sideload as an APK, I don't know any of it, and I wouldn't recommend anything because it's for educational purposes, and everything I say is for educational purpose. So I don't know anything about it, but for the Frida is a tool to help you to do with your job. It works on non-rooted device, but if you think about how Android is built, there will not be many tools which will work for non-rooted device to do the things that rooted devices can. So that's logical. Wouldn't ARAID ProGuard obfuscate any effective? So the main thing, the ARAID ProGuard is not the security for the reverse for the reverse engineer to and also the people who want to do harm to your application. It's kind of side effect, you know. For me, the ProGuard and ARAID, okay, it makes some work harder, but not too much, because as you saw it from the JDEX, and it depends on the skill of the who does this reverse engineering. It depends on the skills. You can reverse it even on the assemble level. You can rename, retype variables. When I see the application, I see the patterns, how they're built, where is the Dagger modules, what are those, okay, which architectures they're using. Okay, probably shared preferences will be in this class, and it will be there. And so this is quite easy when it comes after the practice. So the thing is that you have to practice more, and ProGuard is not actually a solution. It just makes a little bit harder for you, and nothing more. Okay, and how can I detect from server-side device under such attacks? Oh, good question, good question. So you can use, first of all, the Google's library, which called the safety net. so you can attest and check your application if your actual device is compromised or not, and the check will go through your server, and your server should check it with Google and get back to your device. So, and also you can have some monitoring tools on it, but mostly you can't. If it's well made, you can't. We'll be so those last questions, and of the time. So we'll slide after presentation. Of course, it will be available, and I will drop the link, and it will be on my Twitter. Really great talk. But the best way to stay in touch with it, follow me on Twitter. It's Tato Kutalia. You can Google Tatocaster, and you can find me on all the major social networks. So thank you everyone for the great questions, and I hope see you again.